Alright, so here's the explanation of the coordinates of the point of intersection, or P of theta, of a 30-degree angle. We have here theta equals 30 degrees in a unit circle. So we have the radius equals 1, or r equals 1. If you can see, on the right side we have 1 unit, left side we have 1 unit, below we also have 1 unit, and up there we also have 1 unit. Remember that all radii of a circle are equal. So we have the 30, 60, 90 right triangle. It says that here the side opposite the 30-degree angle, or the smallest angle, is half of the length of the hypotenuse. Now, looking at the triangle that we draw on the coordinate plane, we have here the longest side, or the hypotenuse, r equals 1 because it's a radius. And then we have the side opposite this is this side. Okay, so we have here 1/2. Now what we'll have to do is to compute for this side, which is actually on. Okay, so we have here x squared equals 1 minus 1/4. We rewrite 1 as 4 over 4 minus 1/4. Then x squared equals 4 minus 1, that is 3 over 4. To find the value of x, we have to extract the square root of each side. So x is equal to the square root of 3 over square root of 4 is 2. Therefore, x is equal to square root of 3 over 2. Y is 1/2. Again, r is equal to 1 because it's a unit circle. Therefore, the coordinates of P of theta, or the point here, is square root of 3 over 2 and 1/2. Alright, so let's proceed with another angle, which is 60 degrees. We have here the illustration. The x-axis is the horizontal line, y-axis is the vertical line. Then we have the unit circle, so we draw another angle. This time it's theta equals 60 degrees. 60 degrees. So if we draw a broken line here, will form a right triangle. Again, the longest side is the radius, r equals 1. So we have to solve for both x and y. Remember that the interior angles of a triangle is 180 in total. So if this is 60, of course this one is 90 because it's right angle. 90 plus 60, we have 150. So what's left is 30. Okay, that's why we have 30, 60, 90 degree triangle. So this one is 30 degrees. Remember, on the first example, we mentioned that if you have 30 degrees, the side opposite that, so that's the x, the side of the x-axis. So the side opposite 30 degrees is half of the length of the longest side, the hypotenuse. So that is x equals 1/2. Okay, that's already in the theorem. Now we have to solve for y. Alright, so y will be from the formula x squared plus y squared equals r squared. Okay, let me rewrite it for you again. The Pythagorean theorem, we have a squared plus b squared equals c squared. So rewriting that in the context of the Cartesian plane, we have x squared plus y squared equals r squared. So we already have x, that is 1/2 squared, plus y is unknown, and then r is 1 squared. So 1/2 times 1/2 is 1/4, plus y squared equals 1 times 1 is 1. So using addition property of equality, we'll add negative 1/4 on both sides. This is y squared equals 1 minus 1/4. Alright, so 1 minus 1/4 is equal to, alright, that's equal to 3/4. Because a while ago we've already solved this. We have actually 4 over 4 minus 1/4. So we have to extract the square root for both sides. That is y equals square root of 3 over square root of 4 is 2. So here we have y is equal to square root of 3 over 2. Notice that this time the coordinates were interchanged. Okay, A while ago, we have x is square root of 3 over 2 and y equals 1 half. This time, x is 1 half and y is square root of 3 over 2. That is 4 theta equals 60 degrees. Why were they interchanged? Okay, because the position of the angles were also interchanged. A while ago, we used 30 degrees here and 60 on the other side. This time, 60 degrees is here. So take note of these values. We have p of 30 degrees equals p of pi over 6 equals the square root of 3 over 2 and 1 half. On the other hand, p of 60 degrees equals p of pi over 3 equals 1 half square root of 3 over 2. Okay, so we'll be using these values for the next few more examples. 30 degrees equals p of pi over 6, which has the coordinates pi over 3 over 2 and 1 half. Now, we have p of 150 degrees equals p of 5 pi over 6. It's equivalent in radian measure. Notice that if we draw 150 degrees on the Cartesian plane, its reference angle is 30 degrees. So we base the coordinates on the reference angle of the given angle. Therefore, p of 150 degrees is p of 5 pi over 6 has the coordinates of almost the same with p of 30 degrees because it's its reference angle. But since it's located at the second quadrant, we'll use the sign negative for x because it's on the left side, and then positive for 1 half because it's at the upper part. Alright, so for p of 210 degrees, we have this angle. So from here, the initial side going down up to the third quadrant, the reference angle is also 30 degrees because if we draw up to here, that's 180, so we have an excess of 30 degrees. Alright, since it's located in the third quadrant, we have to put negative and negative on both the x and the y axis. Negative, negative. So same numbers, almost, but the signs are different. And for the last one, for this example, we have 330 degrees. Notice that we have the reference angle 30 degrees because the complete revolution is actually 360 degrees. Now we have p of 330 degrees or p of 11 pi over 6 is equal to positive on the x-axis because it's at the fourth quadrant and negative on the y-axis. It's located below. Right, so here are the signs of the coordinates of the angles with 30-degree reference angle from quadrant 1, quadrant 2, quadrant 3, and quadrant 4.